All right, and we are back. 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 Welcome. All right, and we are back. And today we're back with another reaction video. And again, if you've seen the title of the video, you already know what we're here for. I'm sorry for the long wait, ladies and gentlemen, but we are back with Alien Biospheres. Yes, clap, editor, make sure you throw in the claps in there, okay? And yes, ladies and gentlemen, we are back. We are doing our thing. We're going to be learning about stuff. This is episode 9, so we're going to be learning about the tropical rainforest. So that's going to be a fun one. Who doesn't like a tropical rainforest? Let's see how this one gets created. Let's see how it changes the biosphere, if you will, added another dimension to it. I mean, we already had swamplands. We already had kind of like foresty areas, the fields and stuff like that. We got oceans, obviously. So, this is a nice little thing. Next thing we got to get is the Arctic. We can see what the Arctic's doing. Actually, we kind of touched on the Arctic episode or two ago, so we kind of know what the Arctic's doing. Let's get more in depth in it, but I did like what we heard so far. So, ladies and gentlemen, if you've been waiting for this, I'm not going to keep you for long. I do want to say though, if you are watching this video but you haven't subscribed to the original content or seen the original content, I'm gonna need you to go ahead and do that. Link will be in the description below. Go ahead and do a look at Biblaridion. Maybe that's part of the problem is you not know how to pronounce his name. Look in my comments. There are plenty of people who are going to try to correct me myself on how to pronounce the name. Ask any of them and they, or just look at their comments, hey guys, comment down below. How do you pronounce Biblaridion? And then you guys like that comment and all that stuff, and the link will be in the description below. That's the most important thing that I was trying to get to before you guys distracted me, so stop doing that. Oh yeah, while you're over there liking and commenting and all that stuff, make sure you like, comment, and subscribe to the channel. You never know what I'll put out or when it'll come out either. I got you there, buddy. Yeah, so if you haven't already, make sure you do that. It's all fun. Something really cool happens when you hit the like button. It's I can't tell you now, it's a surprise from YouTube. Just know it does happen. Yeah, with that being said, we're gonna get right into it. Oh, I do got to bring this up. I know I like never bring this up, but I will try to bring it up this one time. That is, if you guys don't like, comment, and subscribe. More importantly, subscribe. YouTube will come through that door right over there, and they will. Alien Biospheres 9 Tropical Rainforest.
This alien planet is brought to you by Campfire Technology, who are currently running a holiday sale for their new software, Campfire Blaze.
Hey, shout out to Campfire Blaze. This video's kind of old, but I don't know. Maybe check them out. See what they're doing now. I don't know what the current promotions are, but go ahead and see what they're doing now. Go check them out.
For more information, check out the link in the description or stick around until the end of the video.
You know what? He'll probably still have the link in the description. But yeah, we'll try to stick around to the end of the video. I'll let you know exactly what they do. But obviously you already know Campfire, what they do with all the promotional stuff and all the gaming and putting all the, it's fun stuff. They do it all. So, if you're into like D&D or stuff like that, I'm pretty sure that's the one, Campfire Blaze, place to go.
Last time, we saw how the drying continental interior resulted in the formation of the first deserts, tundras, and seasonal areas, all of which are characterized by extreme temperatures, low precipitation, and low biodiversity.
Okay.
But while the ever-changing climate has reshaped large portions of the landscape, there are a few areas which still experience a climate suitable for supporting lush forests, as they've done since the invasion of land over 100 million years ago.
Hey, shout outs to Dragon. This is actually really incredible.
Most of these areas will occur around the equator, which, due to being more or less perpendicular to the sun's rays, receives the highest levels of solar radiation per unit area of any latitude on the planet, which not only provides more energy for photosynthesis, but also results in constant high temperatures with little to no seasonal variation. In areas near the ocean, this heat will drive extremely high levels of precipitation, with some regions, like the eastern coast of the supercontinent on the windward side of the mountains, receiving 2 to 5 meters of rain every year. The ample sunlight and water will promote abundant plant growth, with the trees here being some of the largest in the world.
Okay.
One clade of xylophytes endemic to this area may specialize for reaching enormous sizes, ensuring that they have the greatest exposure to the light. To provide additional support and stability, their roots may grow outward to form a wider base.
This trunk looks different. It doesn't look as like slimier and stuff as the other one. It does have like less sulfur or like the sulfuric chemicals in it or something. What's going on there? Maybe I'm just personally getting more adjusted to the trees. Is that it? Am I getting better with the trees, ladies and gentlemen? Have you been seeing less tree hate within these videos? I'm still not a huge fan of them, but they have grown on me. If you catch my guys, please don't click off the video. I'm sorry. I in the moment I thought that was gonna be funnier, but I just don't click off the video, please.
Like the buttress roots,
funnier stuff will happen, I'm sure.
On Earth. These roots will also help the tree gather more nutrients over a wider area, which will be especially useful since the constant downpour leaches a large portion of the minerals out of the soil. To prevent the rain from accumulating on or damaging their leaves,
Tara,
they may evolve special grooves.
Look at this. Look at what Tara drew. Look at what Tara drew, ladies and gentlemen. It's incredible. Praise it. Give it some love. Also, shout out. What microphone? What are you doing? Like, what are you doing? Also, shout outs to real plants. They just look cool in real life. I just like plants.
Drip tips to encourage water to quickly run off the leaves and fall to the forest floor. To maximize dispersal, the gammatangia sprouting from along their trunks may grow into long branches so that the spores fall as far from the parent plant as possible.
Okay.
With all of these adaptations, these xylophytes will become some of the tallest trees on the planet, ranging anywhere from 20 to almost 100 meters in height, and thus we'll call them altophytes. These trees will play a large part in defining the rainforest ecosystems by dividing them into distinct layers, including the forest floor at the foot of the trees, the understory among the trunks and low branches, and the canopy within the dense foliage around the tops of the trees. While all forests share this structure to some extent, the sheer size of the altophytes will accentuate this stratification and provide a greater density of niches than any other biome. And with over 100 million years of uninterrupted evolution under an unchanging, hospitable climate, the inhabitants will have had plenty of time to undergo specialization for every niche the forest has to offer, resulting in the greatest biodiversity of any habitat on the planet, with the eastern rainforest alone accounting for as much as 10% of all terrestrial species.
Now, I feel like this is also this has got to be the same for like Earth, right? Like the rainforest does have a bunch of creatures in it, like the biodiversity of rainforest is incredible. So I'm imagining the same reasoning behind this here is the same reasoning behind Earth. Just comment down below if I'm correct on that. I'm sure I am. Matter of fact, comment down below just how correct I am and always am, and how much you love me, and how much you think I'm really cool and really incredible and really handsome. Just all those type of things that you guys normally comment. Just do that stuff.
One of the primary differences between each of the rainforest layers is the availability of sunlight. The vast majority of light is blocked out by the canopy, with the rest filtering down through the understory such that only 1 to 2% of it reaches the ground. Most low vegetation will struggle to grow in such dim light, so the forest floor is surprisingly open and free of undergrowth.
Okay.
On this alien planet, though, the chemophytes have an advantage in that they can resort to chemosynthesis in the absence of light, which, although it's not nearly as efficient as photosynthesis, will still provide enough energy to support a carpet of smaller plants along the ground. Despite this, the forest floor will still be fairly spacious, perhaps enough to accommodate quite large animals such as the ancestral megalobrachids, dromaeopods, and diatomaceans, although the trees may still be too dense for especially large animals like the titanopods. The ground vegetation will predominantly consist of brachyphytes, which have a larger proportion of their surface area dedicated to photosynthesis
Come on.
and chemosynthesis than other clades of chemophyte, giving them an
These
edge
things
in the
gotta
moonlight
evolve though, right? These things are definitely gonna evolve into something even cooler.
conditions. As we've touched on previously, larger leaves will lose water faster through transpiration and will also be at greater risk of being damaged by the wind.
So they'll get smaller.
However, there's certainly no shortage of water in the rainforest, and the
True.
surrounding trees form an impenetrable barrier against the wind. So
True.
plants growing on the forest floor can afford to
Even
evolve
bigger.
exceedingly large leaves to absorb as
Yeah,
much of the
okay.
scarce sunlight as possible. However, the lack of wind also presents a problem when it comes to dispersal, since most chemophytes rely on the wind to spread their spores and gametes. In the previous episode, the tylophytes were able to circumvent the limitations of wind dispersal by evolving animal-assisted or biotic pollination,
Yeah.
whereby passing animals get the plant's gametes stuck along their bodies and unwittingly spread them to other plants across the desert. This method of pollination is fairly passive and unspecialized, relying on the host simply brushing against the plant's gametangia by accident. But there do exist more efficient means of pollination that ensure that the pollinator will seek out the plant intentionally. Deceptive pollination, also called dispersal mimicry in some contexts, involves the plant producing false signals that pollinators mistakenly identify as food, shelter, or something else of interest. For example, Dracula orchids mimic the appearance and scent of mushrooms to attract fungus gnats. Carrion flowers like the Rafflesia look and smell like rotting meat to attract carnivorous flies and beetles, and the bee orchid has evolved flowers that resemble female bees, which entice males into trying to mate with them. In all of
I'm sorry. Can we just talk about how crazy this last one is? Like, this got to show some type of sentience in like plant life, right? Like, are we gonna say, we can't just say, oh, it was a coincidence that this one flower that wanted bees to get at it made itself look just like a bee. I mean, it's not like photocopy, but it's like if you're a bee and you know maybe got bad vision, you're just looking around, you're buzzing you're fast, and you're like, oh, whoa, is that a bee? She look kind of nice over there. And you're just going over there, and now you're pollinating a flower. Like, bro, first of all, blue ball and the bee like crazy. Second of all, like, you know, now you're just like you can't tell me like over time did this kind of have like, you know, oh, it kind of looks like something. It looks, or no, at the beginning it looked nothing like a bee. Nothing like a bee at the beginning. And then over time it was just like, yeah, let's get some of these you know, some of these up here. You know, no bees wanted to bang it, you know, and it was just like, all right, let's get some patterns up in here. No bees wanted to bang it. Then they got the shape right and they were like, yo, to catch a bee right here, to catch a predator bee, that, my gosh. And also these things look creepy. Like if I saw these Dracula plants in real life, I would probably run away from them. And I've seen this before. Obviously, it looks like a Pokemon, but you know, we don't even have to acknowledge that for real. I feel like I would hate these things in real life. They smell like rotten meat. I don't like the smell of rotten meat. I don't like bugs. This thing loves bugs. We're not, you know, we're complete opposites. I'm a human. It's a plant, you know, like we're on two opposite ends of the spectrums. Me and you, we couldn't be friends. Me and you, we probably could be friends. I feel like you could have this as a house plant, but then it's like, yo, can we not? Can you stop trying to bang bees or have bees bang you? Like, I don't want bees in my apartment. Honestly, I really couldn't be cool with any of these. That, long story short, the reasoning behind all that rambling is that I would not want to own any of these plants. But if I were to own one of them, it would be this last one.
Female bees, which entice males into trying to mate with them. In all of these cases, the pollinators are tricked into making contact with a plant and getting covered in pollen, which they'll then inadvertently spread to other plants every time they fall for the same trick. Because it ensures the plant is visited more frequently, this method of pollination is much more reliable and effective than the one used by the tylophytes, so it seems likely that it may also evolve among some of the rainforest brachyphytes. The asexual brachyphyte colonies will grow in any area with sufficient light and nutrients, forming large patches along the forest floor. In one clade, the parts of the plant that emerge above the ground may evolve to collectively mimic the color, shape, and texture of rotting meat, and to
Okay.
exude a pungent stench to attract scavengers. The male gametangia may suspend their gametes within a slimy coating on their outer surface, which will get stuck all over the body of any animal that comes to investigate, and will hopefully be subsequently deposited into the female gametangia of another colony. Due to their resemblance to carrion, we'll call these plants conophytes.
Okay.
Unfortunately for these
Now I'm looking for like a mushroom type plant, that's gonna be put in the forest. That's gonna be in the forest to help all the other plants surrounding it grow. Like if you guys know about like normal rainforests and stuff and like forests, a lot of times like mushrooms, be used as like a support for other plants and vegetation in the area. So like mushrooms, because they grow underground and they have that whole connective network, they also grow and connect to the roots of like trees, and they can help nourish them, and also get nourishment. And once they have a connection of different trees and it's like an actual forest, then it can help support life throughout the whole forest. They can help the trees support other trees. It's actually really incredible how mushrooms and fungi work in nature and stuff. Really, really good stuff to look up one day.
There'll be plenty of scavengers around to serve as potential pollinators. The
All right,
rainforest's
Henry.
hot, humid
All right,
climate
Era.
accelerates decomposition, such that despite the constant flurry of organic debris falling from the upper layers, the forest floor stays relatively clear. Among the decomposers will be the necrophytes, which, unlike most other plants, don't need to worry about the lack of sunlight on the forest floor, as they can
True.
obtain all of their energy through saprotrophy. The necrophytes will be assisted in their decomposition duties by the abundant malacoforms, which remain by far the most numerous and diverse of all animal clades, comprising
Okay.
many tens of thousands of species. They're also some of the smallest animals, ranging in size from less than a millimeter to a maximum of about 5 centimeters, and as such, they can't rely on
Not gonna lie, if you see these things in real life, like let's say we don't have, like let's say we have our current bugs, but then like random alien comes from space, it's just like he brought flies with him, and these are the flies. If these are the creatures that we got to start dealing with, people are gonna freak out. Like spiders are already crazy enough. Imagine seeing this thing come out of your tub drain or something. Imagine this thing with the pincers, coming at you, and you're like, oh crap, and then you smack it, obviously, and you're like, all right, now I gotta I gotta make sure I don't get poisoned. Because obviously we don't know if these things are poisonous or not, when you first see it. Obviously we know because we've seen the videos, but, the person who hadn't seen these videos is just like, whoa, 10 centimeter, little creature coming at me. I smacked it. Oh my gosh, I think it kind of cut me a little bit. I got to get a tetanus shot now. Like, come on, bro. These things would be crazy to see. If these were already your normal bugs, you deal with it. But if you're getting introduced to these things as like, hey, we have bugs, but then these things also show up, bro. Who's not freaking out? You on your phone right now, you're freaking out.
size, speed, or armor for defense, so up to this point they've survived by simply reproducing in vast numbers. But the innumerable niches offered by the rainforest may prompt the evolution of new strategies to avoid predators.
Okay.
Many species may evolve camouflage patterns to help them blend in with the red leaves and
I
dark
like that.
cuticles of the
I like that.
rainforest vegetation. But with tens of millions of years of continuous specialization, some clades may take this to a greater extreme.
Yeah, you gotta have the
Defensive mimicry
veins.
occurs when one species, termed the mimic, evolves to resemble another species, referred to as the model, such that predators are unable to reliably distinguish between the two. If the model is a species that predators would naturally have no interest in or would actively avoid.
Okay, guys. Sorry, I know I'm pausing a lot, but this is good information here. How can somebody explain to me in the comments, how does this start happening in nature? Like, how is this coincidence? Is this like, hey, right place, right time? Is this like, hey, over time your body is like, you had these features, so you survived, and now you just keep, passing that gene on? Is that it? Like, how one, like, Was it like one of these creatures back in the day was just like brown, like this color, and the other one was just kind of like white, another one was like orangish, then they kind of made it, had like a little really brown one, and then he met like another one that was just, the right color tones until eventually hundreds of millions of years later, this thing was created. Is that how it is? But like not even purposely. Like I seen a video where a guy purposely created a snake with a smiley face just by breeding snakes until the patterns all started to match like a smiley face, and he did that within his lifetime. It probably only took like a couple of years with snakes. I'm pretty sure they have kids really quickly. So it was like, obviously, I feel like I know it can happen. I know we can breathe stuff like that, but you know, it takes a long time. Nature did this multiple times by complete accident. Is what, like, this thing knew it should have a mimicry of a hole in the leaf. That's insane to me. This thing. I mean, I'm gonna be honest. Out of the three, this one's kind of, the least impressive. It is impressive, but this tail looks like a real leaf right here, and this thing looks like it'll mess you up. This thing, I would just think that's a leaf. I'm a human. I know it's not a leaf. I would think that's a leaf. Look at the bite out of it. It looks like a caterpillar was going after it. Was that on purpose? Is that coincidental? Like, no, I don't know. People in the comments, explain this to me.
Then the mimic will likewise be left alone and will therefore benefit from their resemblance. This puts a pressure on the predators to more effectively distinguish between the mimic and its model, which then puts a further pressure on the mimic to evolve a more convincing resemblance. And given enough time, this arms race can result in mimics and models appearing virtually identical.
Jesus Christ. Look at this. Guys, look at this. Look at this. Look at you. If you're on your phone right now, I need you to stop doing whatever you're doing. Stop washing those dishes. Stop, cleaning up after that baby. Look at this thing on this screen right now. This is insane. Guys, if you're driving, stop paying attention to the road. I'm joking. Keep paying attention to the road, but also pause it and then look at this. This is insane.
For those malacoforms that feed on leaf litter or decaying organic matter, an
Yo,
ideal
Kiwi.
model for mimicry will be the copious necrophytes that blanket the forest floor around them, which carnivores will have no interest in. As well as a pale coloration, they may evolve a crest on their dorsal surface, reminiscent of the necrophyte's small vestigial meristem, and their boneless limbs may elongate to resemble the plant's roots. When faced with danger, they may raise their eye stalks and their hind limbs off the ground in imitation of the necrophyte's gametangia, and as long as they maintain this posture and keep still, most predators will simply pass them by. To contrast them with their necrophyte models, let's call these mimics necroforms. But other malacoforms may opt for a more formidable defense. Many organisms on Earth have evolved to protect themselves using biologically produced poisons or toxins, which can vary in potency from simply leaving an off-putting taste to killing anything that ingests it within a few minutes. Toxicity is especially beneficial for small organisms that can't rely on other forms of defense. So one clade of malacoforms may evolve to produce a toxin that causes a severe burning sensation in the mouth and throat of anything that tries to eat it. However, poisoning a predator does no good if the prey dies in the process.
Real. Like, one of the worst parts about that is you still have to be, like, pretty much eaten. You need, like, like a venom? That way you can offensively use that ability. Like, I'm going to attack you and then you also get, go out. And then maybe have a little bit of resistance.
And therefore, in stark contrast to the necroforms, it's in the poisonous species' best interest to stand out as much as possible, so that their predators can recognize them and know not to eat them. Aposematism is the signaling of danger to a potential attacker, often accomplished with bright warning coloration, which predators then learn to recognize and avoid. On Earth, aposematic coloration most often incorporates patterns of red and yellow, but on our alien planet, this wouldn't be very visible against the background of the red foliage, so the poisonous malacoforms may instead tend towards bright blue or green colors, making them easy to spot even in the low light of the forest floor. and ensuring that members of this clade, which we'll call chloroderms, will be able to effectively communicate their poisonousness to predators. But once this association has evolved, it will be open for exploitation by other clades. A common subtype of defensive mimicry is Mullerian mimicry, in which two or more poisonous or otherwise well-defended species evolve similar aposematic displays, presenting a sort of universal warning signal. For example, the monarch and viceroy butterflies, which both produce toxins that make them unpalatable to predators, have evolved to look virtually indistinguishable, which increases the prevalence of the shared warning signal and offers more opportunities for the predators to associate it with danger.
I'm not gonna lie, which one do you guys like more? Obviously, I feel like I like this one more. This one just feels more like, more intense with it. The black. This one looks more faded, like odor. This one looks like it's fresh, like it's really got a lot of poison in it. I like this one.
Signal and offers more opportunities for the predators to associate it with danger. In light of this, if another clade of malacoforms were to independently develop toxicity, then instead of evolving their own aposematic display, they may simply mimic the signature coloration of the chloroderms, taking advantage of the fact that predators already have an aversion to it. The presence of this new clade, which we'll call cyanoderms, will also provide a benefit to the chloroderms by reinforcing their shared danger signals, which will be further strengthened by every new species that adopts the same coloration. A collection of species that share the same aposematic coloration is called a mimicry ring, and may involve a large number of species from very distantly related clades, such as how orange wings with black tips have convergently evolved among certain species of poisonous beetles, wasps, and moths. So the tropics of our alien planet may be home to many unrelated species of poisonous malacoforms that all mimic each other's warning coloration, ensuring that every member of the mimicry ring will be left well alone.
Now I'm thinking about like the different animals on Earth that look the same but are also like similar, that are like poisonous and stuff, and it's like there are a lot of like snakes that probably look alike, right? Like that probably happens a lot in the snake community, like if you're a snake, let me know how often that happens to you, where you get confused for another snake. People are like, "Oh, whoa, I thought you were a python," and you're like, "Whoa, bro, I'm freaking poisonous. You thought I was I was contracting you? No, bro, I'm poisonous. It's crap." And you're like, "Oh man, never mind." They just walk past you. And then it's like, "Oh, whoa, I thought you were a freaking king cobra." And then you're like, "Well, just because I have the flaps, you think I'm a king cobra?" Freaking discrimination. That's when the snakes, as a snake, you be like, "Oh, you're discriminating against me." And then you bite them. And then it turns out you were a king cobra because you lied. It's like one of those, a snake thing. All right, guys, give me one more chance. Don't unsubscribe. Don't click off the video, please. One more chance. I am kind of tired, right now. Give me a little bit of a break. I'll do better next time.
Moving up from the forest floor, the availability of sunlight gradually increases, providing more energy for photosynthesis and making it easier for plants to grow. In this regard, the xylophytes have a huge advantage thanks to the rigid support tissues within their stems and trunks, which let them grow taller than any other clade of plants. But equally, their towering trunks will provide a platform that smaller plants may use to reach heights that would normally be inaccessible to them. Epiphytes are plants that grow on the surface of other plants, spending all or part of their life cycle off the ground. Epiphytes are particularly common in rainforests, as the struggle for sunlight incentivizes many plant species to take advantage of the surrounding trees to provide the support they need to reach the bright upper layers. In this case, some caulophyte species may evolve to adhere their elongated stems to the altophytes, creeping up the trunk and producing a crown of leaves once they reach high enough to experience suitable levels of sunlight. And because they can reproduce asexually, new individuals will branch off from various points along their stems, forming a web-like clonal colony that slowly envelops the entire tree, somewhat like strangler figs on Earth. These epiphytes, which we'll call reptophytes, will have access to the same levels of light as their altophyte hosts without needing to invest in the development of rigid support tissues, and so they may see a great amount of success and form a large portion of the understory vegetation. Some species of brachyphytes may evolve to become epiphytes as well. Unlike caulophytes though, brachyphytes have no stem to speak of, as their main bodies have reduced in size to protect the meristem, So rather than growing up the side of the trunks like the reptophytes, they may never make contact with the ground at any point
Oh,
during their
wow.
lives, obtaining nutrients from the fallen organic debris that accumulates around them and forming tightly concentrated colonies along the branches. Once again, though, these plants will face a big challenge when it comes to reproduction. Like the conophytes, they can't rely on wind for dispersal, so they may also develop a mechanism of animal-assisted pollination. But rather than using deceptive pollination, these epiphytes may attract animals using a more honest approach. On Earth, the most common method of pollination involves the plant providing a reward for the pollinator, usually in the form of nectar or some other source of nourishment provided from special glands, or nectaries. Like deceptive pollination, this has the benefit of encouraging animals to actively seek out the plant. But unlike deceptive pollination, where there's an evolutionary pressure on the animal to identify and avoid the plant's deception, this method incentivizes the pollinator to find and feed from the plant as effectively as possible, which makes the plant's reproduction much more efficient. On Earth, the most commonly employed pollinators are flying animals like birds, bats, and insects, which can cover great distances and therefore maximize the plant's dispersal. So on our alien planet, the Opisthophterans, being the only clade of flying animals that have evolved thus far, may be prime candidates for use in pollination. Although most Opisthophterans species retain the carnivorous diet of their elastospondyle ancestors, the brachyphytes may be able to attract some of the smaller, more generalist species by secreting a nectar-like liquid from glands at the base of their leaves. They may position their male gametes at the end of long, hair-like filaments, such that when the Opisthophterans secure themselves to the plant to lick up the nectar, they brush against these filaments and get the gametes stuck along their undersides. Meanwhile, the female gametangia may evolve into tall, tube-shaped structures, into which the Opisthophterans may unintentionally deposit some of the male gametes they have accumulated from other plants.
Okay.
Once this relationship develops, both the plant and the pollinator will evolve to make it as efficient as possible. The evolution of nectar represents an entirely new food source, and therefore a new niche for animals to specialize for. Nectarovores are animals that feed predominantly or exclusively on nectar, which, although low in many essential nutrients like proteins and minerals, has a high sugar content and is very easy to digest, which lets the animal power a very high metabolism. Some of the most common Opisthophterans in the rainforest are the Leptopterans, which also have the maneuverability to navigate through the dense foliage in search of these epiphytic brachyphytes, which may give them the edge they need to evolve into the planet's first dedicated nectarovores. The most important adaptation for a nectarovore is to have mouthparts optimized for extracting nectar, which in these Leptopterans may manifest as a long, extensible proboscis to reach down into the plant's nectaries. Nectarovores also tend to be very small, as plants typically don't produce enough nectar to support large body sizes, so these forms may shrink down to some of the smallest of all Opisthophterans, rarely exceeding 10
Even
centimeters in wingspan. The evolution of these specialist nectarovores...
I was going to say, I thought 10 centimeters would have been small enough, but hey, I'm no wingologist over here.
Which we'll call Picopterans, will prompt the brachyphytes they feed from to become as easy to find and pollinate as possible. One of the most common ways this is accomplished in plants on Earth is with brightly colored flowers to increase the plant's visibility. However, while Earth plants typically have flowers that grow from the tips of their branches and contain both the male and female reproductive components as well as the nectaries, chemophytes have gametangia that grow out from the base of the plant and contain only one of the two sexes of gamete, while the nectaries only occur on the main plant body. Because all of these elements are housed in separate areas of the plant, instead of evolving multiple distinct flowers, it may be more likely for these brachyphytes' floral ornamentation to be distributed across the entire plant or even the entire colony, with the cuticle and the filaments supporting the male gametes taking on vivid, eye-catching color patterns.
Okay.
Due to this distinctive coloration, we'll call these plants chromatophytes. As they've evolved in tandem, the Picopterans and the chromatophytes will depend on each other for their mutual success, which may drive the evolution of even more specialized relationships between individual species. For example, the flowers of the Passiflora plant have evolved such deep funnel-shaped petals that its nectar is only accessible to a single species of pollinator, the sword-billed hummingbird, which has evolved...
Bro, what am I looking at here? Can somebody explain to me what the heck, like, what am I looking at? I don't... This is the only... You evolved just to get this plant. And this plant evolved just for this bird. Bro, what are y'all doing? Just marry each other already. Jeez, what's happening right now?
The longest beak relative to its body size of any known bird species.
Yeah, because what other bird would need a beak this long? You're trying to get this one plant. Think of how many other plants you could have got, bro. You're over here trying to get this one thing. It's like, why do you need a? Forget this thing. Let this thing go away, okay? You focus on being a bird, okay? And you're like, I feel like you're a less effective bird now. Other birds make fun of you because it's like, yo, look how long his bill is. That's weird. Like, you can't even hang around this guy. Freaking knocks you around every time you're near him. He just like looks this way, and it's like, oh, you're freaking knocking me off the branch here, buddy.
So long, in fact, that it can now only feed from the passiflora. This benefits the hummingbird because it won't face any competition for its food source, and it also benefits the plant because it guarantees that the next flower the bird visits will be another passiflora. In the same way, each species...
I'm not gonna lie, shout outs to the passiflora plant. That bird, bro, horrible life choices right there, bird. You're making horrible life choices. I'm gonna tell you that right now. Worst decision you ever made. Now you pretty much made yourself dependent on this one plant. You can't even get to other plants. This is what I was talking about before, man. I tried to give you the one-on-one, bro. You're not even listening. You're just a bird at the end of the day. And this is a video from 4 years ago. It doesn't matter, whichever one.
Species of Picopteran may specialize to feed on and pollinate only one or a small number of chromatophyte species, which in turn may evolve so that only a single species of Picopteran can feed from them. However, pollination is only one aspect of reproduction. Once a female gametangium has been fertilized and the diaspores develop, the plant will need a way of dispersing them to new areas. Without any wind below the canopy, any diaspores the plant releases will either fall straight to the forest floor, where they'll probably die from lack of sunlight, or land right next to the parent plant, and thus will need to compete with their own parent for resources. To mitigate this problem, the chromatophytes might once again employ the assistance of animals. There are two main ways this can be accomplished. The simpler but less common option is to evolve burrs, or specialized dispersal structures that cling to the skin of any animal that brushes by them. Some of the chromatophytes may opt for this strategy, turning their fertilized female gametangia into detachable pods covered in sharp hooks to cling to the wings of the visiting Picopterans. The burrs will eventually be dislodged during flight and hopefully land in a suitable area for the diaspores to take root. But a more common and more efficient option is, much like with pollination, to attract potential dispersers by offering them a reward. Once fertilized, the female gametangia may swell into bulbous, fleshy structures, turning into what might be called fruit. Like fruits on Earth, these structures may be brightly colored and packed with nutritious tissues, which will entice a wide variety of animals into eating them. The diaspores contained within the fruit may evolve a tough outer casing, like a seed, to let them pass through the herbivore's gut without being digested, ultimately getting dispersed in the animal's excrement.
Real?
Like the evolution of nectar, these fruits will present a brand new food source, and therefore another new niche for herbivores to adapt to, leading to the evolution of the planet's first frugivores, or specialized fruit eaters. Frugivory has a lot of advantages over folivory, or leaf eating, as leaves are quite nutrient poor and contain tough, indigestible tissues, forcing most folivores to put up with a low metabolism and to invest in large, complex guts to
honestly, 3 best examples of low metabolism animals right here.
What little nourishment the leaves provide. In contrast, fruits are rich in nutrients and very easy to digest by design,
Real.
giving frugivores the energy to power a much more active lifestyle. So
bro,
shortly after
who's over here eating leaves when you eat fruits and vegetables? And look, come on, bro. You're over here eating leaves? You didn't even wait for fruits to be invented? Come on, man. No patience. Zero patience.
All, some rainforest herbivores may specialize to feed...
Bro acting like he couldn't wait a few million years to eat, man. Come on, bro.
Exclusively. One clade quite likely to exploit the frugivorous niches are the ancestral platodonts, which were some of the first creatures to ever evolve scansorial or climbing behaviors, and have since become some of the most common and successful arboreal animals. Although some clades of platodonts have adapted to live more or less permanently at ground level, like the Adaphithias and the Copotarsons, in the rainforest, the forest floor doesn't offer very much food or shelter, and comes with a risk of attack from predators like the dromaeopods. So most rainforest platodonts may remain within the relative safety and plenty of the understory and
The
canopy. And
trees,
after
yeah.
tens of millions of years, they may become so specialized for life in the trees that, like many arboreal species in rainforests on Earth, they'll live their entire lives without ever coming down to the ground. The chromatophytes may provide an impetus for this specialization, as their energy-rich fruits can only be found along tree branches, and so, like the Picopterans, these specialist platodonts may co-evolve with the chromatophytes to both clades' mutual benefit. But navigating the complex, variable terrain of the upper layers will present a multitude of difficulties for these platodonts. In many places, the branches that the chromatophytes grow along will be very narrow and precarious, and even a single misstep could send the animal plummeting to its death. Possibly the easiest and most effective way to minimize this risk is to become smaller, which will let the animal support its weight on thinner or weaker branches, as well as increasing the width of the branch relative to the animal's body size, making it easier for it to maintain balance, and it will let them squeeze through tighter or denser areas of vegetation. These species,
I was gonna
which
say,
we
like,
call
they need to learn how to hook on, like not like with their claws, but kind of like tail adaptations. That's what I mean. Yeah, tails. Get tails.
scandipods, will be some of the smallest platodonts, but they'll thrive on a diet of mixed fruit provided by the chromatophytes, and in turn become some of the rainforest's most common seed dispersers. But another clade of platodont may arrive at an entirely different solution to the issue of maneuvering through the trees.
Tails.
Suspensoriality involves hanging below the branches rather than moving along the top of them, as seen in many primates, sloths, and in bats.
What the? Who even knew the name of this? I thought this was just climbing. My bad, scientists. I didn't know what you guys did all day. I didn't know you had a name for literally every single thing. This is why you guys get paid the big bucks. This is what you guys are doing with your day. Suspentorial. Suspensory. Yeah, it's hanging on below
A
branches.
key advantage
You
provided by this
hang
form
instead
of
of
locomotion
climb.
is that, since the animal is already suspended from the branch, it won't need to worry about losing balance and falling off, meaning the width of the branches won't pose as much of a limit on their maximum size. The most fundamental requirement for suspensoriality is to evolve large claws or digits to grip the branches securely enough to let the animal hang beneath them effortlessly and indefinitely. This may occur among one clade of platodonts when the claws at the end of their walking limbs evolve into prominent hooks, and their ankle joints evolve a high degree of articulation to let them wrap around and grasp branches. They may also
Bro, what did I say? This is why you always believe me. Please believe me. I be knowing what I'm talking about,
evolve
people.
longer limbs to help them span gaps in the vegetation and to reach for food such as the fruits of the chromatophytes. Most of these platodonts, which we'll call harpactopods, will be larger than the scandipods, and although fruit may still constitute a decent portion of their diet, they may also retain more generalist feeding behaviors, subsisting on leaves, malacoforms, and other small prey. But once suspensoriality has evolved, it will open up a number of new, more exotic locomotive possibilities.
Okay.
Brachiation is a rare form of locomotion in which the animal moves by swinging arm over arm through the trees. On Earth, this is only known to have evolved among primates, with some groups, like gibbons, evolving such efficient.
Now, doesn't this also count as suspensoria or suspensotorian climbing under the trees, or is this different because they're swinging, not just like actively climbing? But can you consider, like, if you saw a kid swinging on, you'd be like, he's climbing around. Is that the same, or do you not consider this the same? Answer that to me in the comments. Reply. Say the stuff.
Brachiation that they can swing through the canopy at over 50 kilometers per hour, making them some of the fastest of all arboreal animals. This speed helps escape predators and cover greater distances in search of food. So although the rarity of brachiating species on Earth implies that it only evolves under very particular circumstances, there's a chance it may also evolve in a clade of harpactopods. While typically the limbs of most suspensorial animals are of the same or similar length to make them all equally effective in clinging to tree branches, brachiation is correlated with disproportionately long forelimbs, which let the animal span greater distances between handholds. Despite the fact that the osteopods have a much greater number of limbs than vertebrates, these harpactopods may still make use of only a single pair of limbs for brachiation.
Why I look like you're doing pull-ups right now? Like, bro, stop aura farming right quick.
Keeps the body stable and gives the arms sufficient freedom of movement. However, their pedipalps are still used for handling food, and the frontmost locomotor limbs are attached to the base of the skull, which may not be practical for bearing the weight of the whole body. So somewhat bizarrely, it may be the second pair of legs that evolves into the primary brachiating limbs, becoming almost as long as the rest of the animal's entire body. The joints connecting these limbs to the body will need to be extremely flexible to give them a wide enough range of motion to swing forward and back in one swift movement. To help them rapidly latch onto and let go of branches, these limbs may evolve an extension of the ankle bone, almost like an extra finger, to oppose the sickle-shaped claws and close around the branch like a wrench.
Okay.
In contrast, although the remaining limbs may still occasionally be used for locomotion, they'll play only a minor role in brachiation, most of the time simply hanging below the body. And since they no longer need to bear the animal's weight or retain any capacity for walking, these limbs can afford to shrink so as to not get in the way. This will give the animal an overall shape and style of movement similar to that of a pendulum, redirecting the momentum generated on the downswing to propel it forward.
I like this.
With the exception of the Opisthophorans, this clade, which we'll call the Tanabrachids, will be some of the most mobile animals in the rainforest.
Wait, haven't we already...
Frugivores, omnivorous generalists,
I feel like we got one of these
and
before.
hunting predators among their ranks. But there is...
I feel like we got a long arms before. Maybe that's just me.
one other way of moving through the tree.
Whoa, are they mating? Or are they fighting? I don't know. I think they're fighting.
Yet another clade of platodonts. As we discussed in Part 6, many arboreal clades on Earth have evolved a patagium to let them glide between branches and to act as a parachute to ease their descent. On our alien planet, this occurred among the elastospondylus about 60 million years ago. But within the crowded canopy of the rainforest, some of the platodonts may convergently evolve along the same lines, evolving a patagium stretched between each of their 8 walking limbs. Initially, this will simply help them leap between trees, but perhaps with time and the right ecological conditions, they may be able to take this development even further. It's worth emphasizing that powered flight is a very rare trait, so it's by no means inevitable that it will evolve among these gliding platodonts, but with the sheer number and variety of niches offered by the rainforest, the opportunity may eventually come along for them to evolve into the planet's second clade of flyers. However, a major difficulty inhibiting this development will be the existence of the Opisthophorans, which are already a well-established and extremely diverse clade, and will present a considerable source of competition for any species adapting for flight. For these platodonts to have any chance of exploiting aerial niches, they and the Opisthophorans will need to undergo some form of niche partitioning, similar to how on Earth, bats have specialized for nocturnality to avoid competition with diurnal birds. In this case, the platodonts' characteristic broad teeth will be much more efficient at chewing through plant matter than the Opisthophorans' oral tentacles, so while most Opisthophorans will be predators or nectarovores, these gliding platodonts may be able to more effectively fill the niches of flying herbivores, and thus the two clades will avoid competition with each other by specializing for different diets. On top of this, their feeding habits may also be influenced by the metabolic demands of flight itself. Curiously, folivory is very rare among flying animals, possibly because leaves don't offer enough nutrition for a high-energy activity like flying, so as these platodonts specialize for flight, the prevalence of leaves in their diet may decrease, being made up for by the ample energy provided by frugivory. To turn their patagia into full-fledged wings, their second and third pairs of limbs may elongate and become more heavily...
This thing looks super cool. Like, something about this part here, this middle section, this is cool as crap. Man, I like that.
Muscles to contribute the bulk of the aerodynamic force. To fuel the constant flapping of these wings, they'll need to evolve a larger lung and heart, and more powerful breathing muscles for greater oxygen consumption, as well as thermoregulatory mechanisms.
Go ahead and do that.
To maintain an optimal metabolic rate.
Get it done.
Once
Get
they've
it done.
established themselves, this clade may expand into all the niches that the Opisthophorans have thus far left vacant, undergoing rapid diversification as they spread into other habitats across the planet. We'll call them Pleuropterans. But while all of these various clades of platodont will be very successful, they won't be the only arboreal specialists. As the majority of rainforest niches are concentrated in the canopy, many clades typically only found at ground level may be encouraged to take up arboreality, giving rise to species like tree porcupines, tamanduas, and silky anteaters. Such a development may occur among the Desmostricans, which have thus far been largely precluded from the arboreal niches by competition from the platodonts, But once again, niches are so plentiful in the rainforest that it might be possible for at least one clade of Desmostricans to expand their range.
Bro said actually, you know what? Come on, man. Come on. We ain't really been messing with you for a minute. Come on, bro.
Into the trees. Their bodies and limbs may become longer and evolve gripping surfaces on the underside, letting them cling to tree trunks and clamber among branches, and their whip-like oral tentacles may evolve to bore through the crevices in the plant's cuticles and pluck out the malacoforms within. Let's call this clade the Dolichostricans. However, while moving into the trees will help them evade the ground predators, it will also expose them to new threats like the predatory Tanabrachids. Since they're nowhere near fast or agile enough to outrun predators, many species may simply rely on their banded armor for defense. But some species may complement this with another form of toxicity.
Beautiful.
Unlike poison, which simply needs to be ingested in order to take effect, venom needs to be delivered directly into the bloodstream.
Venom! Editor, you know what to do.
Venom glands usually evolve from other chemical-producing structures like scent, salivary, or reproductive glands, and are usually situated near or within fangs, quills, or stings to puncture the target's flesh and allow the venom to pass into the blood. In these Dolichostricans, the venom glands may derive from a series of excretory glands along their flanks, used by their aquatic ancestors to maintain the balance of salt and sulfur in their blood. To penetrate the attacker's skin and administer the venom, the sides of their banded shell may evolve into sharp quill-like points, which will normally lay flat for ease of movement, but will stick up when the animal arches its back or
Brother, if you see this thing, I need you to run the other way for me, okay? At this point, I don't even care how big he tells me this thing is. This thing is freaking insane at any size. What the heck is this?
Getting stung by these quills may result in severe pain, irritation, and swelling near the point of contact, which should be enough to discourage most predators. Like the distantly related chloroderms and cyanoderms, these Dolichostricans will want to make their dangerousness as obvious as possible, and so may evolve similar aposematic color patterns. And just like with their malacoform relatives, once the predators have evolved to recognize and avoid these animals, which we'll call pronacanthids, another clade of Dolichostricans may take advantage of this by evolving to mimic their danger signals. However, it would be quite unlikely for another clade to convergently evolve the pronacanthid's venomous quills in exactly the same way, so the mimics may simply rely on their aposematism to bluff their way out of dangerous situations. Batesian mimicry occurs when a toxic or dangerous species is mimicked by a relatively harmless.
Hey, it's the snakes that I was wondering if they got confused with each other. Some of the, like that.
One, as can be seen in animals like milk snakes, which share near identical aposematic coloration to highly venomous coral snakes, and in hoverflies, which mimic the black and yellow stripes of wasps without bearing any stinger. Unlike Mullerian mimicry, Batesian mimicry doesn't require the mimic to already have some form of defense to back up its warning signals, providing a very inexpensive...
You think one of these snakes saw a coral snake and was like, oh man, ain't nobody messing with him. I gotta be like this guy. And then it's like, all right, I think I got the stripes down. But then it's like, oh, I went black, yellow, black. Oh, his is yellow, black, yellow. Oh, no. You know, it's like one of those situations.
Expensive, yet effective form of protection. Among the Dolichostricans, one clade may become Batesian mimics of the pronacanthids, not only evolving the same general body shape and coloration, but also long structures on their back that resemble the pronacanthids' quills, but don't actually contain any venom and aren't stiff or sharp enough to pierce skin. These animals, which we'll call nothocanthids, will rely on their deceptive appearance as their sole means of defense, and both they and the pronacanthids will be free to forage for malacoforms without fear of attack. But venom can also be used for offense as well as defense. Many predators use venom as a way of quickly subduing prey before it has the chance to escape or fight back. In our alien rainforest...
Guys, didn't somebody mention this before? Like a really cool, handsome, smart YouTuber that you guys are currently watching? Didn't he mention that earlier? Like, poison can be used offensively? Whoa, I wonder who that was. Maybe like, comment, and subscribe to all his videos.
Royal predators are the ancestral elastospondylus, the flightless cousins of the forms that evolved into the Opisthophterans. Although their range and maximum size have decreased over the past 60 million years as a result of the drop in atmospheric oxygen levels and the related shifts in climate, they'll still be common and capable ambush predators found in most areas of woodland across the planet, being especially prolific in the crowded canopy of the rainforest. Perhaps in one clade of these elastospondylus, the digestive glands on the inside of their mouths may evolve to produce a potent venom, which will be delivered into prey along special grooves in the animal's teeth. This venom will give these creatures, which we'll call kentrodonts, a major advantage in tackling large or fast-moving prey. One clade may even specialize for hunting flying animals like the opisthophorans and pleuropterans, which are too agile for most other predators to catch. Gripping the underside of a branch with their hind limbs, they'll lie in wait with their spines bent into a tight curve, striking at anything that flies past with a venomous bite that paralyzes the prey before it has the chance to struggle free, somewhat like the bat-eating behaviors seen in the Amazonian giant centipede on Earth. To aid in this lifestyle, this clade may evolve elongated bodies to increase their striking distance, as well as powerful forelimbs to ensnare prey and restrain it long enough for the venom to take effect.
Okay.
Like most flightless elastospondylus, these forms, which we'll call aspidonts, will be ambush predators, and thus rely on prey coming to them. But another clade may take this a step further by employing yet another variety of mimicry.
Another one?
With the exception of dispersal mimicry, all of the forms of mimicry we've discussed so far are categorized as defensive mimicry, used by prey species to avoid or deter predators. But predators can also make use of what's called aggressive mimicry, luring...
Bro. Microphone, calm down. This made itself look like a plant? You gotta be freaking kidding me. This is like, what is this, like a mantis? Like a praying mantis? Bro, this, oh my God, again, the adaptations that would have had to happen over time. When did they become pink? When did they gotta add a little green in there? Because, I'm a plant, I gotta have a little green, gotta pop a little bit with some green. This thing's like a fashion designer.
Prey by resembling something of interest. For instance, the tongue of the alligator snapping turtle imitates the appearance and movement of a worm, tricking fish into trying to eat it, only to end up getting eaten themselves. And many clades of mantis have independently evolved to mimic specific kinds of flower, attracting pollinators such as butterflies, which the mantids then catch once they're within reach. For the kentrodonts, an ideal model for aggressive mimicry will be the chromatophytes, which already attract nectarovores like the picopterans and frugivores like the scantopods and pleuropterans. Initially, these kentrodonts may simply use the chromatophytes' leaves and gamete-covered filaments as cover to implement their ambushes. As they specialize for this hunting technique, they're likely to evolve color patterns that help them blend in with the bright blues and greens of the plant's cuticles, letting them stay hidden until prey comes within range. At this point, this is only considered camouflage, not full-fledged aggressive mimicry, which entails that the animal's appearance actively attracts prey rather than simply helping the predator avoid detection. This may be accomplished with the evolution of a red crest on their back that mimics the chromatophyte's leaves and meristem, which the picopterans and other nectarovores will come to in search of nectar, only to be killed by the kentrodont's venomous bite. These animals, which we'll call phyllophorans, will be much smaller than the aspidonts, but thanks to their potent venom, they won't need a great size to make a kill, and will be among the most specialized predators in the canopy.
Okay.
As this rainforest has the highest density and diversity of species of any habitat on the planet, it would be impossible to adequately catalog the millions of clades that inhabit it, and the handful that we've discussed here will represent only a tiny fraction of those that...
Just assume there's some of everything in here, okay? If you're thinking about, oh, is that in there? Yes. Is that in there? Possibly, but maybe smaller. Oh, is that other really big animal in there? No, it's not. But there's a smaller thing that kind of does something that it does, Think of it like that, there may not be a big old 80-foot giant monster in there, but there's probably like some good 10-foot ones, waiting for you. There's like a 15-foot predator out there. You don't really hear about it, but it gets at you. I'm surprised they haven't gone into any like snake-like creatures enough, but the mimicry was crazy this episode.
That for rainforest life over the 60 million years or so since the altophytes first evolved. But while the residents of this lush jungle will have enjoyed the stable, benign conditions for all this time, The planet at large is about to go through an important juncture in its history.
What?
One that will influence the course of life for over 100 million years to come.
Wait, what's about to
In the
happen?
next episode, we'll
What?
explore the fate of all of the clades we've discussed so far when the supercontinent finally breaks in.
Bro, the supercontinent is, oh my gosh, this is crazy.
Thanks to Campfire for sponsoring
Thank you,
this
Campfire. Oh yeah, I told y'all we was gonna stick to the end. Let's hear about Campfire.
episode.
Come
Campfire
on.
Blaze is a browser-based application that offers all the
Browser-based.
tools and features you need.
Guys, do you like browsers? Do you like being based? Hey, check this out. Have you ever wanted to play D&D but like be like actually cool with it? Take a look at this.
Plan out and document every
Plan
aspect
out
of your
everything.
storytelling
Guys,
and building.
you ever wanted to write a
lot of
book?
Blaze's features already
You ever just want to write a book, but you're like, man, I am so good at writing, but not good at like notating everything and setting up my story. Guess what? Campfire.
come with the free version.
Guys,
including
you ever just
entries
wanted to like have digital Campfire and do stuff that Campfire lets you do? Campfire.
characters, maps, timelines, species, languages, magic systems, and the option to share your work
Boom.
and collaborate with other users in
Boom.
real time. But if you want more,
Guys, you ever needed assistance with your work and you needed some guidelines from other users or other creators? Bam, now there you
you can
go.
upgrade your interface by adding new modules to customize your layout to suit your own personal world-building needs.
World
Each module
building.
can be individually purchased either as an ongoing subscription or as a one-time payment, meaning you only pay for the features you need. Not only that, but for their holiday
Whoa, look at these prices. Let's see. Let's just take a look at how expensive this is. So the full thing probably costs you like $100 or something. But then look at this. You could just be like, all right, I just need this timeline. One good time. Bam. $1.
payment, meaning
Hold
you
on.
only
Let me
pay for the
let me
features
see what
you
these
need.
prices was hitting for. So the annual cost, lifetime cost, monthly cost. Okay. Characters. You can get some characters. You know, the free tier list. You know, get 10 characters. Bam, $1 a month. Not bad, right? You know, how long you got to make this? Annual cost, $10 for a year. Oh, wow. Not too bad. Not too shabby if I say so myself. But for a lifetime cost, it's only $30. Lifetime. It may take you 5 years to write this book. Guess what? $30. Bam. Timeline. This whole timeline thing. 20 different events. You know what? $10 for annually, $30
Only that,
for
but
the
their holiday
lifetime.
sale,
These are not bad lifetime prices. Now, if we're adding this all together and making it be like, oh, that's 60, then it's like a 105, then it's 127.50, then it's like 157.50, and it's like, all right, if this is gonna be under, if this okay, this is another $15. So if it's gonna be under like $200, let's say it's $100 for the lifetime membership for this. Bro, I don't wait. How much was the
subscription and
membership? Let
lifetime
me hear.
purchases for all Blaze modules, which you can get by using the code HOLIDAYBLAZE at checkout.
Yeah.
To sign up for Blaze or to learn more,
Now that's probably already expired, but see what deals he currently has. I'm sure he might still be working with
or
Blaze.
check out the link in the description.
Check out his links. But also, let's say that if you got the lifetime for $100 or less, you are like, it's actually a steal. I'm gonna say that.
Thanks also to the fans over on Discord who
Yeah,
contributed
thank you,
artwork for this
fans.
episode,
Thank you.
and who saved me an
Yes.
enormous amount of time
Chris,
and effort when making these
Era,
videos, while simultaneously making them look
Crafty,
a hell of a lot better in the
Crocodile,
process.
Dark
The
Sony,
main server and the
microphone
Biospheres
falling,
fan server in the
Hate
description.
Heath,
And once again,
Henry
a massive
Space,
thanks to all the patrons whose continued support
Interface
makes videos like
5,
this possible.
Joshua,
Thanks for watching, and I'll see you in the next
Kanchi,
video.
Kiwi, the choreographer, Kwai Bug, Krav, M1LA, Mira, no, Monica, Omnipotent, Utakana, Pocket Goblin, Rich Nella, Ron Critter, RTC Studios, Sean, Sketchy Dude, Stormy, yeah, everybody. Shout outs to everyone involved. Tad the Water Tribe. I'll finish it out. Tara, Turquil, Unstoppable, you Jenner, Zero the V Man. Yeah, shout outs to all those guys. I think that was the end. And guys, that was a great video. I like I feel like I learned a lot about mimicry specifically. This was a very mimicry heavy episode where I had to learn about animal mimics. So there's predators. My microphone hasn't learned how to stay still. There's predators. There's like prey. There's the defensive mimicry. There's like, oh, I'm also poisonous, but he's poisonous, so we're just gonna look alike. There's I'm not poisonous, he's poisonous, so I'm gonna look like him. There's like the whole like, psh, bro, we're just twinning, right? Like I like that whole we're just twinning thing. We're both poisonous. We just got the same jacket on. That's cool. Uh, obviously the whole I'm not poisonous thing, I feel like that only gets you so far. Animals, a lot of them might not test you, but one of them might test you and be like, oh wait, this guy wasn't poisonous. Haha, screw him, I'm gonna, I get free eats right here. So yeah, a lot of great stuff we learned there. Next episode I'm sure is going to be great because the continents are going to be, it's going to be multiple continents now. There was one, the life of unity, just one. Now it's two. We're going to be split in half. Who knows what happens to the animals in the middle? They just fall into the ocean. They become sea animals. That's not really how it happens, but maybe. And yeah, guys, that was another one. That was a great one. I got a lot of editing to do, so this will be on the list of things that need to get done as soon as possible for you guys. I don't know when I promised this for you guys, but I'm sure you've been waiting long enough, so we'll go ahead and get this out as soon as possible. So, as always, if you made it this far, I do want to say thank you. I love you. Bye. Glad you didn't click off after those couple of jokes, ladies and gentlemen. I obviously was kidding around there, having a good time if I do